Welcome. Let's understand surge impedance and surge impedance loading. Let's start with a discussion about what is surge impedance. The general expression for the surge impedance of a transmission line is given as shown here, where R is the resistance per unit length, considering the two conductors to be in series. L is the inductance per unit length. G is the conductance of the dielectric per unit length. C is the capacitance per unit length. J is the imaginary unit. And W is the angular frequency. The energy stored in the electric field of an overhead line can be represented as 1 by 2 CV square. At a similar way, the energy stored in the magnetic field is 1 by 2 Li square. At the threshold condition of having electric energy equal to the magnetic energy stored in both fields, that is as if E equals Em, it results from the equations above, neglecting resistance, equals V by I equals square root of L by C. The characteristic impedance, or surge impedance of a uniform transmission line, usually written Z0, equals square root of L by C, equals square root of XL into XC. The surge impedance of a transmission line is also called the characteristic impedance with resistance set equal to 0, that is, R is assumed small compared with the inductive reactance. The power, which flows in a lossless transmission line, terminated in a resistive load, equal to line's surge impedance, is denoted as the surge impedance loading of the line, being also called natural power. Under these conditions, the sending end voltage ES leads the receiving end voltage ER by an angle delta, corresponding to the travel time of the line. Let's start with a discussion about what is surge impedance loading. For a three-phase line, surge impedance loading equals square of line-to-line voltage divided by Z0, where Z0 is the surge impedance of the line. Since Z0 has no reactive component, there is no reactive power in the line. QL plus QC equals 0. This indicates that, for SIL the reactive losses in the line inductance are exactly offset by the reactive power supplied by the shunt capacitance, or I square, WL equals V square, WC. SIL is a useful measure of transmission line capability, even for practical lines with resistance, as it indicates a loading when the line reactive requirements are small. For power transfer significantly above SIL, shunt capacitors may be needed to minimize voltage drop along the line, while for transfer significantly below SIL, shunt reactors may be needed. The Ferranti effect describes the voltage gain towards the remote end of a very lightly loaded, or open-ended, transmission line. Underground cables normally have a very low surge impedance, resulting in ASIL that is typically in excess of the thermal limit of the cable. Hence a cable is almost always a source of reactive power. Figure shown here is a graphic illustration of the concept of surge impedance loading. This particular line has a SIL of 450 megawatts. Therefore, the line is loaded to 450 megawatts, with no MVAR flow. The MVAR produced by the line will exactly balance the MVAR used by the line. Surge impedance loading of typical overhead lines in megawatts are given here for information. Now let's see methods for increasing SIL of overhead lines. For increasing the surge impedance loading of an overhead line, the following ways are possible. Voltage increase, or reduction of Z0 through one of the measures. Reducing phase spacing. Increasing number of conductors per phase bundle. Increasing conductor diameter. Increasing bundle radius. introducing bundle expansion along the span, but keeping the conventional bundle spacing, inside and near the tower. The characteristic impedance or surge impedance of a uniform transmission line, usually written Z0, is the ratio of the amplitudes of voltage and current of a single wave propagating along the line, that is, a wave traveling in one direction in the absence of reflections in the other direction. Surge impedance is determined by the geometry and materials of the transmission line and, for a uniform line, is not dependent on its length. Thank you for your attention and time. More stuff coming soon. Don't forget to subscribe.